Okay, good morning, everyone. So, today we are actually going to look at metals and alloys as a construction material. We've previously looked at wood, we've previously looked at cement, we've previously looked at concrete, mortar, and other construction materials. So, this is the next one we are going to take a look at. So, at the end of the lecture, you go through this content, you go through the introduction of metals, ferrous alloys, and non-ferrous alloys. So, at the end of the lecture, you start by discussing what you should be able to do. The first thing is you should be able to identify and distinguish between the essential metals used in construction. The second one is to comprehend the concept of alloys and their role in construction materials. Three, to be able to relate the properties of specific metals to the application in construction. And finally, to understand the characteristics of different iron ore varieties. Okay, so you go through this one step by step before the end of the lecture. Okay, so for the introduction, let's take a look at a metal. So first of all, we all know what a metal is. We use a metal in our day-to-day lives. The phones we use, like almost everything, metal is in our daily lives from one form or the other. So for instance, the phones we use, the fan in your room, the light bulb, the charger in your phone, the laptop, the chair you are sitting on, your door handle, even some of you, your doors. Okay, so metal is very important, and metal is actually used in various forms of engineering, such as the structural roof, structural members. So, for instance, the frames for the roof, in the roofing materials, reinforcing materials, such as the steel iron rods in concrete. We have the pipes, we have the tanks. Okay, so these are the engineering ways that we use metal in. And among all metals, iron is actually the most common one. And it's also the one which is very abundant. Okay, and they stated that there's about 5% of iron present in the Earth's crust. Okay, so that is also for iron. Now, let's take a look at the classification of metals. Okay, so metals are broadly classified into two major groups. And the first one is ferrous metals, the second one is non-ferrous metals. Okay, so for ferrous metals, these are metals that have iron as their primary component. An example is pig iron, an example is cast iron, another example is wrought, and another example is steel. Okay, they have magnetic properties, strength and abundance make them the backbone of industry development. They have specific magnetic properties, specific strengths, and they are very common, so it makes it easily available. It makes it the go-to choice when you are working with metals in the industry. But aside the ferrous metals, you also have non-ferrous metals. So non-ferrous metals are metals that do not have iron as their main component. An example is aluminum, copper, and zinc. And they are mainly known for being lightweight, they are mainly known for being corrosion resistant, and they are mainly known for being more conductive compared to the ferrous metals. Now, why is this distinction important between the ferrous and non-ferrous metals? In general engineering, the choice between a ferrous and a ferrous metal can actually affect everything you are doing, from the weight of the structure you are trying to erect to the resistance to environmental factors like corrosion. For instance, steel, we know steel iron rods, but iron steel, yes. Like for instance, it's a ferrous metal, and one thing steel is actually known for it is its strength. Okay, and aluminum, which is also a non-ferrous metal, is chosen in applications where the weight reduction is key. Like let's say for instance, in an aircraft, you can't use steel to build an aircraft because the aircraft will be very heavy, and one prized property of an aircraft is that it's supposed to be light, and one metal that they prefer in that situation is aluminum. Okay, so in aircrafts or in even design of a car, an automobile device, on automobile machines. Okay, so try and look at a choice between steel and aluminum in a construction scenario, and try and imagine which one will you go for and why. Okay, so also the last thing is an alloy is a mixture of two or more metals. It's a compound that involves two or more different metals. So now let's look at iron. Okay, iron ore. So you're looking at ferrous metals. Okay, so now let's look at the source of the ferrous metals, which is what? The iron ore. So now the iron ore is essentially a naturally occurring mineral aggregate that contains iron in a form of compound and is combined with other non-metallic elements. Okay, now typically the iron ore includes impurities such as carbon, phosphorus, manganese, sulfur, and silicon. Understanding the iron ore is actually crucial because these impurities determine the quality of the iron ore extracted. For instance, let's say with certain impurities that can be tolerated in the products like cast iron, they might be unacceptable in high grade steel production. You see, so this balance is actually fundamental to manufacturing. This balance is actually fundamental in the manufacturing process, and it really influences everything from the extraction methods to the final application. So let's say, for instance, you are tasked to produce a very high strength steel for a skyscraper. You see the way skyscrapers are, they are very tall buildings. They need to be strong. Other than that, the building can fall off easily, and the foundation should be very strong to be able to hold the weight of the above ones. The quality of iron that you use will directly affect the strength and durability of the product. Okay, so depending on the iron ore that you are picking, if you have impurities in a situation like this, you should make use as high quality iron as possible. Okay, so that's for the iron ore. Now let's look at pig iron. That's the next thing we have. So this material is primarily the product that's obtained from the blast furnace process, and it serves as a basic raw materials for producing wrought iron and steel. Okay, so you see that pig iron is actually extracted from iron ores like magnetite, hematite, limonite, and siderite. Okay, the extraction process occurs in a blast furnace, a continuous working furnace where iron ore is reduced, producing pig iron. Okay, now the term pig iron actually comes from traditional shape of the ingots. So this is an example of the traditional shape. Okay, where they resemble piglets clustered like around a sole. Okay, that's why it's called a pig iron. So one thing is, the process of extraction pig iron is actually very energy intensive, and it requires careful control of the temperature and the chemical composition, and any variation can result in impurities and affect the quality of the final product. Okay, so understanding the processes to produce pig iron is actually key for anyone involved. That's for pig iron. The next one is wrought iron. Okay, so it's actually the oldest form of iron process known to man. Okay, so wrought iron is produced by reheating pig iron in a significantly reducing its carbon content. That's mainly the idea. You heat pig iron. Pig iron is already heated from iron ore, so you reheat it, and then as you are reheating it, you significantly reduce its carbon content. The process results in a material that is very malleable and also ductile, and it makes it suitable for decorative work and early construction applications. Okay, a key characteristics of the wrought iron is actually its high purity. Okay, although it does not contain some ions, although it does contain some iron silicates, it has very low carbon content, which makes it less brittle and more workable compared to cast iron. Now, in the past, wrought iron is mainly used in railings and fences and even structural support for buildings. And currently, it has, although these modern construction stuff have moved to steel. Understanding, we don't mainly use most of these wrought iron stuff in recent times, but understanding wrought iron is actually essential for the evolution of the various metalworking techniques. Okay, and advances in alloys to the alloys we use today, from the raw ore to the advances we use today, from we having iron ore to pig iron to wrought iron to the future forms of the iron you are going to look at. So that's also wrought iron. The next one is cast iron. Okay, so for cast iron is another fundamental material in the iron ferrous metal family. Now, unlike the wrought iron, the cast iron actually has a high carbon content. Okay, typically more than 2%. This higher carbon level, along with other impurities like manganese, phosphorus, silicon, and sulfur, gives the cast iron its unique characteristics. Okay, so one critical point for cast iron is the role of manganese. Okay, while small amounts of manganese can be beneficial for the cast iron, okay, if it actually exceeds 0.75, it makes the cast iron very brittle, okay? And this brittleness can actually be a disadvantage in applications where flexibility and important resistance is actually needed, okay? But it can also be an advantage where hardness and wear resistance is required. For example, you can use cast iron in engine blocks or certain cooking ware, okay? So that's cast iron. Lastly, for cast iron, it has the ability to be molded into complex shapes, which has made it a popular choice for various industry applications, for example, from pipes to machines to decorative architectural elements. So the metal pipes we use in our homes, from sink stuff, most are cast iron. You also have machinery, the engine blocks in cars, parts of automobile, engines for trains, other machines that we cast iron, because cast iron can be molded very, very, very easily, okay? That's made it a popular choice. Now it's perfect. So that's for cast iron. The next one is steel, okay? Now steel is the most widely used and versatile alloy in construction material and construction and engineering, okay? So steel is primarily an alloy of an iron and a carbon, okay? With slight variations in the carbon content can lead to significant changes in the property, okay? So steel is actually classified into three broad categories. So the first one is the low carbon or mild steel, which contains up to 0.25% of carbon. Now this is typically ductile, okay, and it's used where ease of fabrication is important. So that's for the low carbon mild steel. The next one is the medium carbon or medium hard steel. So with a carbon content ranging from 0.25 to 0.7, the steel offers a balance between the strength and the ductility. Okay, so that's for the medium hard steel. And the last one is the high carbon or hard steel, which contains 0.75 to 1.5% carbon, which makes it stronger and harder, but then it's less ductile, okay? And it's actually ideal for applications that require high wear resistance, okay? Now, what makes steel so valuable is actually its versatility. Do you get it? Steel can be used for building skyscrapers, for construction, bridges, or manufacturing vehicles, okay? So it depends. Steel is very common, and because steel is very common, that means it also makes it easy, okay, to work with. It's very versatile. It has a different, depending on the carbon content, you can have different properties for steel. Now let's look at non-ferrous metals, okay? So for the non-ferrous metals, the ones we are going to look at is aluminum, copper, and zinc, okay? So as I said, non-ferrous metals do not contain iron as their primary element, and they offer distinct advantages, okay, compared to the ferrous metals. So let's start with aluminum. So one, aluminum is actually extracted primarily from bauxite, a mineral that is essentially a hydrated aluminum oxide. Basically, that's bauxite, okay? So aluminum is actually known for its lightweight, excellent resistance to corrosion, and a remarkable strength to weight ratio, okay? Now these properties of aluminum makes it the go-to choice in aerospace, automotive industries, and even in some construction applications, where if you want to reduce the weight without sacrificing the strength is very important, then aluminum is actually your go-to choice, okay? The next one is copper. So copper is unique because it is found in nearly a pure metallic state in nature, okay? It's actually sourced from minerals such as copper glands, macalite, or azurite, okay? And it actually has a high electrical conductivity and thermal properties. So copper is the key component in electrical wiring for phones, house, and anything that has electronics in it, there's copper in it. And it's also a very good candidate for plumbing systems. So some plumbing systems actually also have copper in it. And the next one is zinc. That's the next non-ferrous metal, non-ferrous alloy. So zinc is a bluish gray material, okay? That's the color of the zinc. And it's typically extracted from ores like zinc sites, calamine, and zinc blende, okay? Now one of its most important role is in galvanization, which is the process of applying a protective zinc coating to steel or iron to prevent it from rusting. That's one important role of zinc. Now, it actually makes zinc an essential player in extending the life of metal structures, okay, especially those in harsh environmental conditions, because with all this, during galvanization, the zinc is kind of melted and is applied like a paint, a finish to a metal, and it makes the metal to be able to, it mainly prevents it from rusting, and it adds an extra layer of strength to the metal structure, okay. So in harsh environments where the environment is conducive for rusting, it is okay. It doesn't easily rust, okay. Now, if you look at non-ferrous metals, all of these have their own advantages, sets of properties and advantages, okay. And when engineers are deciding, they decide based on a certain number of factors. They decide based on the weight of the metal, the strength, the conductivity, and the resistance to environmental damage. Okay, so now we have non-ferrous alloys. Okay, so this is the final thing we'll discuss. So as I said, an alloy is essentially a combination of two or more metals that results in a material with characteristics that are often superior to the individual components. Let's say, for instance, we have Gary normally, we have sugar normally. Gary normally and sugar normally don't really have any kind of use. They all have their individual use case, but if you combine them and add groundnuts and add water to it, it's way better than eating Gary alone, eating sugar alone, and eating the groundnut alone. Essentially, that's what an alloy is, okay. So you pick two or more metals, then the idea is the resulting metal, the alloy that you are creating from a combination of the two or more metals, should have a higher, it should be more superior in terms of characteristics to the individual components. So let's say we take iron and copper, okay. If you take iron and copper, or maybe copper and zinc, when you combine copper and zinc, the characteristics that you are supposed to get outside it should be better than copper individually and zinc individually. So you are going to look at copper alloys, aluminum alloys, and magnesium alloys, okay. So the two principal copper alloys are brass and bronze, okay. So brass is essentially an alloy of copper and zinc, and it actually provides a good workability and corrosion resistance, and it makes it a popular choice for decorative hardware, musical instruments, and plumbing fixtures. Now, bronze is a combination of copper and tin, and it's actually known for its strength and also resistance to wear. It has actually been used historically in the making of coins and ship fittings and also sculptures and stuff. Now, looking at aluminum alloys, the one we have is pure aluminum, which is very soft and relatively ductile, which limits its use in applications, okay. So by alloying aluminum with elements such as copper, zinc, manganese, magnesium, and nickel, its high tensile stress and hardness are significantly improved, okay. Now, this makes aluminum alloys essential for structural applications in aerospace industry as well as automotive and construction sectors. Now, let's look at magnesium alloys. Magnesium alloys are actually lighter than aluminum and typically contain 3 to 10% of aluminum, 1 to 3.8% of zinc, and a small percentage of manganese, which is 0.4. Now, their low density makes them ideal for applications where weight saving is critical, such as sports equipment and electronics, okay. If your phone is very heavy, you find it very hard to use. So these alloys are made such that they have higher properties, but they are also very, very lightweight, okay. Now, in essence, alloy enables us to fine-tune the properties of a base metal to meet the specific demands of the application. Okay, so that's it for this class. Thank you very much.